As promised, we're going to take a look at how to write the equation given a graph. Now, because the cosine function is actually the sine function with a phase shift, you get to choose which function you want to use. And because of the fact that both the sine and cosine are periodic functions, they repeat over and over and over, you get to choose where your endpoints are. So theoretically, every student in the classroom could have a different equation for the same graph, and everyone could be correct depending on where they were looking for their starting values. So first, amplitude. This amplitude is not up for debate. So everybody should have the same amplitude because the graph is the same height as you're looking at it. So to find the amplitude, we can tell there's a vertical shift on this one because it's starting down at -4 and it's going up to 2. When there's no vertical shift, it will be starting at the same negative value as it stops at the positive value. So what you do to find the amplitude is you find the difference between the negative and the positive value, or the minimum and the maximum, and you divide by 2. So the difference between 2 and -4 is 6. Dividing that by 2, we have an amplitude of 3. Now our A value will be positive or -3 depending on where we choose our starting and stopping points, whether or not there's a reflection for our graph. To find the period of the function, you look between either 2 consecutive maximum values, 2 consecutive minimum values, or 2 consecutive x-intercepts. Because of the vertical shift on this one, the x-intercept will actually occur at that midpoint of -1. So I am going to sketch in a little new x-axis for us so we know where we're looking. And because this one starts on the y-axis, I'm first going to show you how to write a sine function for this one because it's a little bit easier. We don't have a phase shift if we have an intercept on the x-axis for our sine function. And then we'll take a look at how to write a cosine function, a little bit more complicated one. So I'm going to call this a sine function. I'm going to call that y-axis my start value, and what I notice is that it's going down from there. So because the sine function without a reflection goes up from its first intercept, our A value we now know is -3. So looking at a full rotation, there's actually, I think I misspoke earlier. I said between 2 consecutive x-intercepts, not true. You can look between 2 consecutive maximums, 2 consecutive minimums, or 3 x-intercepts because there's that x-intercept in between the maximum and the minimum when it's doing that rotation. So if you kind of follow the graph down to a minimum, back to an intercept, up to a maximum, back to the intercept, that is one full period or rotation of the function. And that occurs, it's kind of hard to read this graph, but that's at pi over 2. If you look at the scale is by pi over 4. So our period is pi over 2. So we have to solve to find our b. Remember, 2 pi divided by b equals the new period. So we know 2 pi divided by b equals the period, which in this case is pi over 2. So to solve for b, I actually have to first multiply both sides by b. So 2 pi equals pi over 2 times b, and then dividing by pi over 2 or multiplying by the reciprocal, I get a b value of 4. We also already identified that vertical shift by finding our new x-intercept, so our graph went down 1. Left endpoint and right endpoint, we talked about starting on the y-axis, and we found our right endpoint where we stopped at that one full period of the function. And because sine does start at an intercept on the y-axis, we don't have to worry about a phase shift on this one, so our c value will be 0. So once we find a, b, c, and d, we simply put them into our function. So y equals a, -3, times the sine of b, 4, times x, minus c, well we don't have that phase shift so we don't have to worry about that, and then plus d, which in this case is -1. Alright, we're going to do the same thing with the exact same graph, but this time we're going to write a cosine function. We already identified the amplitude as 3. We're going to leave the a value as positive 3 for now, and we'll come back and change that to a negative for our cosine function if we need to. Period is still pi over 2, so that b value is still 4. D is still negative 1. So far, everything's looking like it's exactly the same. What we need to do now is find that right and left endpoint for the cosine function. The cosine starts at a maximum, so if you don't want a reflection, you find a maximum value. If you would like your a value to be negative, you would start at a minimum value. I'm going to do this without a reflection because we looked at it with a reflection for our sine function. So I'm going to start here at my maximum and then one full cycle down to the minimum, back to an intercept, back up to a maximum. So my left endpoint is halfway between that 0 and pi over 4. Negative pi over 4, I'm going to say is negative pi over 8. My right endpoint stopped between pi over 4 and pi over 2. Again, if you know how to work with fractions, halfway between the two of those is 3 pi over 8. So now I need to find my c value. So I'm going to set up that equation where 0 equals b times x. Well, now we know what x is. X is that left endpoint, so I'm substituting negative pi over 8 in for x, and then it's plus c. Solving for c, when I simplify 4 times negative pi over 8, I get negative pi over 2 plus c. Adding that pi over 2 to both sides, I get a c value of pi over 2. Now right here I could substitute into my function, but I want to double check my right endpoint and make sure that I get the same c value. If I don't, then I either identified an endpoint wrong or I did the math wrong somewhere. So for the right endpoint, it's 2 pi equals b, 4, times the right endpoint, 3 pi over 8 was what I identified, plus c. Simplifying that 4 times 3 pi over 8, I get 3 pi over 2 plus c. And subtracting 3 pi over 2 from both sides, I'm going to turn my 2 pi into a common denominator with my 3 pi over 2. So 2 pi becomes 4 pi over 2 minus the 3 pi over 2, and I get pi over 2 for my c value again. So it checks out, so now I'm going to write my cosine function this time. Swallow. So I have y equals, and because I decided to start at a maximum, I don't have a reflection, so I've got that 3 times the cosine of b times x plus c plus d. So those are two different equations for the same graph, again depending on where you're looking at for your phase shift and whether you're starting at an intercept or starting at a maximum or a minimum value. For your U-try problems, again, these problems take so much time that for the next several lessons we're going to be looking at questions and summaries for our U-try, and we'll discuss what we do and do not understand before we start our assignment.